Hello, class. I am Mr. Sutton, and today we're going to be doing skill 28 notes over misleading data. We're going to talk about three ways that data can be misleading. We're going to talk about unrepresentative data, which is data that is drawn from a biased sample that does not represent the whole population. We're going to talk about deceptive graphs, which are graphs with inappropriate slash misleading scales or missing labels or data. And we're going to talk about faulty reasoning, which usually is someone mistaking correlation for causation. Just because there's a correlation does not mean that the one thing caused the other to happen. Correlation does not mean causation. So first we're going to look at unrepresentative data. So our situation is a burrito restaurant claims that on a scale of 1 to 10, 98% of its customers rate its guacamole a 10. It obtained this data from those customers who accepted an offer to fill out a survey online in exchange for free guacamole on their next visit. So we have some questions here. First, who was the survey completed by? How did they feel about guacamole? Yeah, so I said the customers and that most liked the guacamole. In fact, 98% of its customers rated it a 10. Then number two, it says who benefited from taking the survey. So I said those who like guacamole are incentivized to take the survey because they get free guacamole. So the people who like the guacamole are going to be more likely to want to actually take the survey because they see that, oh, I get free guacamole on the next visit. So I'm going to go ahead and take the survey. And since they already like guacamole, they're going to give it a high score. Next part, it says who did not benefit from taking the survey. So I said those who do not like guacamole. So if I'm here and I don't like guacamole and I see this survey, I am not interested in taking it because I don't care about this free guacamole on the next visit. In fact, that might kind of make me decide not to take the survey because I don't want to have to worry about getting the guac next time I go. I do like guacamole though. Next question, it says, based on the answers from 1 through 3, why is the restaurant's claim a misleading use of statistics? So for this, I said people who like guacamole are more incentivized to take the survey based on what we said in these previous answers. Okay, so let's go ahead and take a look at the first you try here. This is, again, unrepresentative data. We have a situation. Delta Airlines received only 29 customer complaints in April, while its competitor, AirTran Airways, received 145 customer complaints. For this reason, Delta Airlines claims that it provides better service than AirTran Airways. So we have some questions following up on that. Go ahead and try this one on your own. Try parts A, B, and C. See what answers you get. Go ahead and pause the video and try this, and I will put the answers up in a moment. So for this, it says, do you know the number of passengers Delta Airlines had? No, we don't. We just know the number of complaints. And it says, do you know the number of passengers AirTran Airways had in April? No, we don't. So since we don't know the sample size that we're drawing from, it could be that AirTran Airways had thousands of passengers and only 145 complaints. And it could be that Delta Airlines only had 29 passengers and they all complained. So I think the percentage is an important piece of information that we're missing here. We don't know the total number of passengers. So since we don't know the sample size, the number of complaints is arbitrary in this case. So that is this where we're getting this unrepresentative data. So let's go ahead and look at the next part of the notes. That's deceptive graphs. So we have a situation here. Lillian created the graph below after asking 8th graders if they ate pizza this week. And first question is, let's analyze the labels. What needs to be added? So for this, I said it needs access labels. First off, we don't know what these bars represent. We're given this over here, that purple is yes, and this red color is no, but we don't know anything based off of this. And we don't know what these numbers over here mean. We're given 84%, but then this goes up to past 110, and then this says 16%, but this barely, it goes past zero. So it needs access labels. I don't know what these numbers represent. And it needs a clearer title. Have you ate pizza this week? That's just a question. It doesn't tell us anything about what this graph is intending to represent. So let's look at the second. And then the second question is where we talk about the vertical scale. So analyze the vertical scale. So for this, I said it's an appropriate scale because we're counting by tens, right? And based off of the size of the data we have, it makes sense. But it does not represent the data accurately. These numbers that we're going to here on the bar graphs don't represent the numbers we have here. So it's not clear what uh, the vertical scale is actually representing in terms of the data we have on this information. For question number 3, it says what percentage of students said yes, what percentage of students said no. That information is given over here. So if you can't read that over there, yes is 84% and no is 16%. And then 4 says, does the graph represent these percentages correctly? No, it simply does not. Again, like I said before, the yes, it looks like it's about like 111, 112, and then the no's, it looks like it's just at like 2 or 3. So definitely does not represent these numbers. These numbers are actually a lot closer than what it seems like it is in this graph. And for the last question, how might this be a misleading use of data? So I said the big thing is the graph does not represent the percentages accurately. Really, all of the information in the graph is right here in the small section that we can barely even read. The yes is 84%, the no is 16%. Everything else is just arbitrary, something that was made up. All the information is right here. So that's the big issue. The other thing is no labels, which kind of hints that this is just not real information, that there's no labels telling us what this represents. And I also said a pie chart would be more appropriate with this type of data. Whenever you're dealing with percentages or fractions, something out of a whole, a pie chart is the best way to go. A bar graph is not ideal for this type of data. So I think a pie chart would more accurately represent the difference in the two sizes. But let's go ahead and take a look at the second U try uh, about deceptive graphs. So we have this time this graph over here that we want to look at and answer these 3 questions about it. Go ahead and try this on your own. Pause the video and I will put the answer up in a moment. Go ahead and try this. So for the first part, it says analyze the labels, what needs to be added. So a title needs to be added. There's nothing here that says what this graph is about. We're just given off to the side that these bars represent home prices. The analyze the vertical scale. The big issue here is that it starts at 105,000 and goes to 125,000. So the fact that we aren't starting at 0 and going to 125,000 makes this difference here seem a lot larger than it actually is. If we were looking at from 0 to 125,000, both of these bars would be towards the top of the graph, but since we're only starting at 105,000, this graph looks a lot smaller, or this bar looks a lot smaller than the 2014 bar. And this is why might this be a misleading use of statistics? First off, again, there's no title, and then the graph makes the decrease in price seem more drastic than it really is. And I think you could argue that this should be a line graph instead of a bar graph as well. Since we're talking about change over time, line graph is probably the more appropriate type of graph for this type of data. But let's go back to the notes, this last section on faulty reasoning. So the situation, an employment agency claims that the average annual salary of the last 7 candidates is placed in jobs is 47,000. The salaries the employment agency used in its calculation are as follows. So we're given the 7 salaries here. This is what is the mean of the data. So I'm going to go ahead and calculate that, make sure that that is correct. So when I added these 7 figures together and divided by 7, I did get 47,000, which is what it says right here. So that is accurate. How many of the salaries are below the mean? 6 of them are, all of them except for this 107,000. So already saying this is the average when most of these figures are below this, all of them except for 1 are below this. 3, are there any outliers? Yes, this 107,000 is definitely an outlier. This is much larger than every other figure we're given. And this is what is the median of this data. So let's go ahead and calculate that. So the median is another kind of average other than the mean that hopefully we're familiar with. If you forget how to find the median, you need to order the numbers from least to greatest. So I did that here. I dropped off the 3 zeros at the end, but this is 34,000, 35,000, 36,000, 38,000, 39,000, 40,000, 107,000. We need to figure out which one is in the middle so we can start crossing things off on the outside. And we can see that 38,000 is in the middle. So the median is 38,000, which is definitely a better representation of this data than the 47,000. We can see more that 38 is in the middle of the data versus 47,000 is over here. Okay. So the next question, how is the employment agency's claim a misleading use of statistics? So I said using mean instead of median makes the overall salaries seem larger than they are. So the mean wasn't a lie, it was the mean, but given that it says that that's the average salary, it does make it seem like more people are getting 47,000 than not. So let's go ahead and take a look at this last U try here. This is the faulty reasoning situation. Consider the claim by the opponents of a law requiring bicyclists to wear helmets. It says helmets cause head injuries. In support of the claim, opponents of the law cite data from 2 towns, Springfield and Centerville. In Springfield, in the last decade, there were 1,783 bicycle helmets sold and 82 head injuries from bicycle accidents. In Centerville, there were 101 bicycle helmets sold and only 5 head injuries. Assuming the data is correct, this means that there is a correlation between bicycle helmets sold and head injuries. However, correlation does not imply causation. What is a more realistic reason for the increase in head injuries in Springfield? Take a second, pause the video, and come up with an answer on your own. So I said more people riding bikes means more head injuries. It's more likely that the causation of the head injuries are the number of people riding bikes. All of these bike helmets being sold are being sold to bicyclists. The reason that Centerville is selling less bicycle helmets is most likely because less people are riding bikes. So it's not the purchasing of the helmets that is causing the head injuries. It's the reason that they need them, which is the amount of bike riding that they are doing. If you have any questions about this lesson or questions from the IIP, please come to my office hours or Ms. Parsons' office hours. I hope you all are well, and I hope you all have a good day.